Hello friends, this is Snigdha Kakkar here. Yesterday we solved combination sum which was LeetCode problem 39. Today we are solving the next level of the problem which is combination sum 2 LeetCode 40. It has been asked in Amazon, Meta and Adobe interviews. I think it would be a good value add for any of the people who are trying to prepare for interviews, be it any company. So let me walk you through the problem and I'll tell you how this problem is different from the previous one and how its solution would differ. We'll be coding in Python. If you like my solution, subscribe to my channel for your daily updates for lead code problems. And let me know in comments if you have a better approach. I would love to learn from you. So let's get going. In this problem, we are given a collection of candidate numbers in a form of array called candidates. And there's a target number target. We have to find a unique combination of sub-elements of candidates which sum up to target. Now, this was the same condition in combination sum, then how it is different? So here, the conditions have been mentioned that each number in candidate may only be used once in the combination. This condition was not there in the lead code question 39. Another thing is the solution set must not contain duplicate combinations, which was also there in the prior question, but look at the example here. Like in this example, the candidates is equal to 10, 1, 2, 7, 6, 1, 5. So you have 1 repeating twice. But you cannot use the same combination like 1 comma 7 which is equal to target 8 and then 7 comma 1 which is also equal to target 8 because they both are actually the same combination. Even though you are using the different one from the candidates, but you are using one. So 1 comma 7 and 7 comma 1 are essentially the same combination. So they are duplicates. You cannot use these duplicates here. So you should have unique combinations and each digit can only be used once. These are the conditions in this question. Now what would be your brute force approach here? The brute force approach here could be like I'm taking this array as an example. So let me take this array 10 comma 1 comma 2 comma 7 comma 6 comma 1 comma 5. So if I take this array as an example, then my brute force approach here would be, say suppose I consider that I am taking 10 as a part of my combination. Then with 10 as a part of my combination, I will be combining 10 with 1 or I can combine 10 with 2 and so on. And I will be checking whether the sum is equal to 8 or not. Now, as you all know that 10 is greater than 8, so any of these combinations will not suffice because none of the digits are negative. So we can reject all these combinations. Now say suppose I decide that I will skip 10 and I move to 1. Now with 1, the combination could be 1 comma 2, 1 comma 7 and so on, right? And then you would further go ahead and you would say, I will go ahead with 1 comma 2 combination. And you make further combinations using 1 comma 2. So 1 comma 2 comma 7 or 1 comma 2 comma 6. But all these sum up to more than 8. So 1, 2, 7 sum up to 10. 1, 2, 6 sum up to 9, which is more than 8. So these will not suffice. So you move ahead, you find more combinations. So say suppose I find 1 comma 2 comma 1 and so on, right? So I will keep on modifying these and I will for each digit I will decide whether I am taking it or whether I am skipping it. That ways was the condition we were trying to solve LeetCode 39, where we for each digit we pick it up and then we decide whether we are keeping it in the combination or we are not keeping it in the combination. And then we were checking the total whether it is equal to target or not. If it was equal to target, we were saving that combination and then moving ahead. That was our approach for LeetCode 39. But what's the issue if we take that approach here? So say suppose we start by deciding that we will take 1 and we'll not skip 1. We'll take 1 and we cover all combinations. So one of those combinations would also be 1 comma 7 comma 1, right? This will be 9. Then another of those combination will also be 1 comma 7, right? So 1 comma 7 essentially sums to 8. So it is a rightful combination and you take it here. Now say suppose I choose to skip this one and I move ahead to 2, then check for all combinations with 2. Then I move ahead to 7 and check for all combinations with 7. And when I'm checking for all combinations with 7, there will be a combination which will come as 7 comma 1, where 1 is the second last digit in this array candidates. So it is a different digit, not the prior one. But again, it's the same combination. So you will end up having duplicates with this approach. And hence, this approach will not work for you. It will be time consuming. And at the same time, it will lead to duplicates, which is not the condition in this question. So, how can you make sure that there are no duplicates coming up? So, to ensure that, first of all, you would sort the array. So, suppose I sort the array to 1, comma 1, comma 2, comma 6, comma 5, comma 6, comma 7, comma 10. So suppose I have sorted the array. After that, when I'm making decision whether I'm going ahead with choosing one digit in the combination or skipping it, then I will not just skip that digit. I will skip all of its occurrences. So if I choose to skip one, I will skip not just the first one. I will skip all the ones subsequently occurring in the array, and I'll move to the next index where the digit is not 1 and it is next digit, which is 2. So that will ensure that if I'm choosing to go ahead with 1, then I have combinations having 1 and there is no repetition. And if choosing to skip 1, then I'm skipping all instances of 1. So there is no such occurrence of duplicates. I hope that is clear. So my one combination of 1 comma 7 will occur, but there will not be another occurrence of 7 comma 1, because either I'm choosing to go with 1 or I'm choosing to skip with all instances of 1. If that is clear, then you also understand that combination of 1 comma 1 comma 6 will also not be repeated, because I'm choosing to go with two ones, or I'm choosing to go with only one, or I'm choosing to go with no ones. So you understand that, I suppose. So what would be the time complexity for such solution? So if you see, for each decision you make, you are making the decision as whether you choose that digit for the combination or you don't choose it. So essentially, you are choosing between two choices. And how many times will you make such a choice? It will be 2 raised to power n, where n is the length of candidates array, because that is the number of times you would be making the decision of choosing a digit or skipping the digit. I hope this clarifies. Now let's start coding. So first of all, like I mentioned, we first need to sort the candidates array. So we will sort it out, candidate dot sort. Once we have sorted, after that we will define the variables. So first of all, we'll instantiate result variable where we are capturing all the combinations that sum up to target. Then this is a recursion approach. We will be using backtrack for inside our backtrack function. And in backtrack, what would be the values? So current combination gets stored in current. There would be index, which will be storing in position, like which index of candidates we are talking about. And then there would be target. Then we'll be passing target, and this target will keep on updating by deleting the current candidate value there. So as soon as this target value equals to 0, you can deduce that you have reached the total you are targeting. And every time you find a combination, you delete candidates I from target and keep on doing that until the target is 0. Now our base condition here would be if target equals to 0. That is, you have found the combination which sums up to your given target value. Then what do? You append that combination to your result. But the current combination is changing every time. So you have to create a copy of it so that it doesn't get modified. That's it. Now there would be another condition. If your target is negative, or you have already seen it as 0, and then you are moving it. If it is negative or equal to 0, then you just return. So these are the two conditions. Okay. Now if your target is greater than 0, in that case, what do? In that case, you first set up your previous value, because you have to compare that previous value with the next value in the candidates to make sure that when you are skipping, you skip all the instances, all the occurrences of a particular digit. So by default, for initialization, I'm initializing previous by -1. Okay. Now we will loop. So for I in range, now you don't always need to run through the entire candidates array. You would run it from current position to length of candidate. what you would check if candidates I is equal to priv. What do you do in that case? If current candidate's I value, that is the digit is getting repeated, for example 1 in this array, then you just continue. This is to ensure that there is no duplicates. Okay. Now you append that current candidate to current combination. And how do you do that? You just append it this way. After that, you apply recursion and you call backtrack. So we basically calling backtrack. What are we passing? We have to pass current. Then we have to pass the next index. The next index would be I plus 1 because you have already looked into I. And then target minus candidate I because you are currently at ith index and you have already looked at candidates I included in your current combination. So you have to subtract it from the target. And when your target reaches 0, that is the time you have found the right combination. Now, another kind of decision you could make is to skip it. For that, you have to modify current combination because you already included candidates I here in row number 29. So you need to take action to remove it, which is current.pop. And then you update the prev. Prev would be updated to current candidates. That way, your prev will always get updated to current value of the ith index. That and you can check whether the next value is equal to this or not. Now you have done everything. Now we can call backtrack. So just call backtrack. Then what all you need to pass? For current array, you will pass empty array, then 0th index because you're starting from 0 and back. So this would be your backtrack initialization. And then finally you can return your result. I think this would work. Let me run it and see. So it's been accepted, submitted. As you can see, the solution is doing really well. And the time complexity would be 2 raised to power n, where n is the number of digits in candidates array. Because this is still brute force, hence the time complexity is more. If you have a better approach, share in the comments here. Also mention if there is any specific question on LeetCode you want me to solve. I would be happy to jump on it. If you like my way of solving the problems or you want your daily LeetCode challenge, subscribe to my channel right away to get your latest update tomorrow for your next LeetCode question. Thank you.